Module 3, Volume. Volume is the analogy of area to three-dimensional figures. Area was the measure of how much two-dimensional space an object takes up. Volume is the three-dimensional measure. It's defined in a very similar way by using unit cubes instead of unit squares as the basic unit measure of volume. Consider a rectangular box that is A units across, B units thick, and C units tall. The total number of little cubes within the rectangular box is given by the product of A times B times C. For instance, if a rectangular box is 4 inches wide, 2 inches thick, and 3 inches tall, its volume is then 4 times 2 times 3, which is 24. The proper units to put here will be 24 cubic inches. This tells us that the rectangular box is made out of 24 cubes whose sizes are 1 by 1 by 1. A special case of the above formula is the volume of a cube. If A is the side length of a cube, then its thickness and height are also equal to A, and so the volume is given by A times A times A, which is more simply A to the third power, or A cubed. This is why a cube as a figure and a cube as a third power have similar names. In the previous lesson, we saw that the area of a parallelogram is base times height. There is an analogous version for three-dimensional figures. A parallelepiped is a solid that has parallelograms for each of its 6 sides, and that all of the parallelograms are parallel to each other. In this picture, the area of the base side and h is the perpendicular height from the opposite parallel side to the base side. The volume of the parallel, or parallelepiped in this case, is then given by the base, which is the area, times the height. Cylinders and cones. A cylinder is defined as a solid made up of parallel lines. Both of these examples are cylinders. The one on the left is typically not what most people would call a cylinder, but under our definition it is. It is a solid which is made out of parallel lines. Some of those rulings are drawn here to make it clear exactly how this solid is made out of parallel straight lines. For every cylinder, the volume is given by the area of the base times the height. The simplest type of cylinder is what we have over here on the right. It's a circular cylinder which is not slanted. Let's find the volume of such a cylinder. The height is h, and the radius of the base is r. To find its volume, we need to find b, the area of its base. Given that the base is a circle of radius r, it follows that the area of the base is b equals pi r squared, as that is the area of a circle. Thus, from the formula b times h, or the area of the base times height, it follows that pi r squared h, or pi r squared times the height, is the volume of such a cylinder. A cone is a solid made out of all lines and all intersecting at a common point called a vertex. The two pictures here show 2 examples of a cone, with the rulings drawn to explicitly demonstrate how the rulings of the surface of all areas converge into one point, the vertex. The solid on the left is still a cone, although typically not what most people would call a cone, but under our definitions it is. The solid on the right is the simplest cone of all, a non-slanted cone with a circular base. The cone consists of a bottom face, called the base, and its height, just as with the cylinder, is the perpendicular distance from the vertex to the base. The volume of any cone is 1/3 of the area of the base times the height. Let's use this general formula for volume to find the volume of a regular cone, with a circular base of radius r and with a height of h. Since the area of the circular base is pi r squared, and we have the b, which is the area of the base at pi r squared, and the height is h, so the volume is given by 1/3 b times h, or 1/3 times pi r squared times h. We can even use this general cone formula to find the volume of a regular pyramid of square base length a and height h, because a pyramid is a particular type of cone. we can see that the area of the base of this pyramid / cone is a squared, because the base is a square. So the volume, which is 1/3 of the area of the base times h, in this case is 1/3 of a squared times h. Another particular type of cone is a tetrahedron. It's a solid made out of all four sides, all of which are triangles. In this example, the tetrahedron has a right triangle base of sides 3 and 4. So the area is 1/3 times 3 times 4, which is 6. So if the area of the base is 6 and the height is 6, the formula would be given by 1/3 of b times h, and 1/3 of 6 times 6 is 12. Spheres. A sphere is defined to be the collection of all points in a space such that all of them have the same distance from a given point called the center. It's essentially a three-dimensional circle. The radius is the distance from the center to any point on the sphere. The formula for the volume of the sphere is 4/3 times pi r to the third power, or the radius to the third power times 4/3 of pi.